In our second demo, we will explore how to solve the following linear optimization problem using the dual simplex method. We are given the following linear problem, which we want to solve using the dual simplex method. First, we need to form the standard form from this linear optimization problem by adding the slack variables and turning the inequalities to equalities and transforming the objective function. From the standard form, we form the Simplex tableau as seen on the screen, and we give it the initial solution where all variables are 0. It satisfies the optimality conditions because all coefficients on the z row are above 0, but it's infeasible because one of the constraints do not hold, for example, this one on this line. We start the dual simplex iteration by finding the pivot row, in this case the S2, since it has the most negative value of these values on the solution column for either one of these variables. Then we move on to find the pivot column, which in this case is the column with the variable x3. And we do this by computing the non-zero ratios between the value in the z row and the pivot row. And here we see the absolute values of these, and by comparing them we find that the ratio on this column is lower than the ratio on this column, and these columns the ratio is 0 because they are zeros, so we don't choose them. In the last part of a simplex iteration, we perform a Gaussian elimination using the pivot row and change the leaving variable to the entering variable. Then we have to repeat this process of the dual simplex iteration until the z row is non-negative and the B column is feasible. And then we obtain this solution where we can read the objective value, which is -9, and also the variable values. And by the strong duality, this is also the optimal solution.